We are going to start this video by looking at the domain and range of a parabola. When thinking about the domain, you need to think about the x values, how far left and how far right. When thinking about the range, you need to think about the y values, how high up and how low down. So I'm going to do a quick example by drawing a parabola, and then we will discuss its domain and its range. Let's start with the domain. When thinking about domain, you should look how far left can this graph go and how far right. Now remember, we are restricted when drawing these parabolas due to space. But imagine this parabola was drawn on a huge big piece of canvas. It would be able to go as far left as you would like and as far right as you would like. It keeps growing in a horizontal direction, and it keeps growing in a horizontal direction like that, and it just keeps going more and more and more. And so we can say that there is no real restriction on its domain, and so this graph can have any x value that you like. So there are two main ways that you could write that out, and I will quickly display those. With the first method, we could say that we could use the crocodile mouth method, where we could say that x is anything bigger than negative infinity and smaller than positive infinity. When doing that method, you would have to say that x is an element of all real numbers. And then some people don't like to use the crocodile method, and so we could rather say something such as, we could use brackets instead, and we could say that it goes from minus infinity up to infinity. When using that method, you only have to say x is an element. Please note that only one of those methods has to be used, whichever you are comfortable with. Now we will look at the range. Now the range is all about the highest that the graph could ever go to and the lowest that the graph could ever go to. So when looking at this parabola, if you looked at its lowest point, you would realize that it can't go any lower than there. But if you look at its highest point, those arrows are trying to show us that this graph could just keep going infinitely, forever and ever and ever. And so this graph can go all the way from -2 up to infinity. And so now I will display the two methods for doing the range. Some important points I'd like to draw your attention to in the range is that the -2 value is included, and so we show that it is included. If you choose method 1, you would have to show it like that, and if you choose method 2, you would have to use the square brackets. We will now try a few examples. Okay, we will now practice some examples. Please note that I will not be doing both methods in these. I will just stick to one of them and trust that you will be able to understand should you be using the other method, because they are very similar. For the first one, we can see that the domain, remember the domain is all about how far left and how far right. For a parabola, it will always be from -infinity up to infinity. With the range, we can see that the lowest part on that parabola is at +2, but it can go all the way up to positive infinity. Note that the 2 is included. With number 2, we can see that the domain is always going to be from -infinity to positive infinity. With the range, we can see that the highest value that this graph would ever have is -4, and the lowest it would be able to go down to is -infinity. So the range will be displayed as follows. Notice that the -4 is included, but infinity is never included. We will now proceed to the last question, where once again the domain is always going to go from -infinity up to positive infinity. And the range, the lowest value for that y value is -2. Notice we never look at the 6 because that's an x value. We're not interested in the x value when talking about range. So it can go all the way from -2 up to positive infinity. And that is the end of that example. We will now talk about the axis of symmetry. Symmetry lines are lines that divide a shape completely in half, where the two halves look identical to one another. I will show this with an example. So if we had to imagine a line that cuts this parabola in half, a few suggestions that I have seen from students in the past. Some initially try to do a line going this way. Remember, that does not divide the parabola into two equal symmetrical halves, so that won't be correct. We could try doing a line going down here, but then the right hand side and the left hand side would not be the same. And so the symmetry line of a parabola is the line that runs right down the middle as depicted like that. And that is the only axis of symmetry for a parabola. Now we need to come up with the equation of that line. So what stays the same on that red line? Is it the y values or is it the x values? Remember, x values talk about going left and right, and y values talk about up and down. Each point on that red line has gone the same point distance to the left or to the right, and we can see that there is no horizontal change in the left or right direction when going down this red line, and so it is the x values that stay the same. What are the x values on this line? Well, we know the x value down here at the turning point is 5, and so the x values at all points on that line would be 5, and so the equation of that axis of symmetry would be equal to x equals 5. Remember, any line that is vertical or horizontal either has an equation that says x is equal to something or y is equal to something. Let's try a few examples. We have to find the equation of the axis of symmetry. Now this is really a quick process. We know that the axis of symmetry is always the line that runs down the middle, and so the axis of symmetry for that equation will simply be equal to x equals to 4. Let's do number 2. Number 2, we know that the axis of symmetry is this line that runs down the middle, and so its equation will be given as x is equal to minus 2. With the last one, it's slightly different because we don't know what the turning point is. But remember, in one of our earlier videos, we said that to find the turning point, you could locate it as the complete middle or the midpoint between minus 4 and 2. So you could add minus 4 and 2 together and then divide that by 2, and what you would find is that the midpoint of those two numbers is minus 1, and so we can locate the x value of the turning point as minus 1. We don't know the y value at that turning point, but that doesn't matter, because to find the axis of symmetry, we only need the x value. And so we could draw that symmetry line down there. It's a little bit, it's not perfectly straight to the turning point, but we could find the equation of that symmetry line as x equals to negative 1. Asymptotes, which we will see in more detail when we deal with hyperbolas and exponential graphs, are almost like these lines that get in the way of the graph. So for example, here we have a hyperbola drawn. Now think about what happens when this graph moves from the right to the left. As it moves from right to left, it cannot jump over this dotted line over here. Well, it can jump over, but it can't ever become that value. So it has to jump over, and then it carries on over here, and then carries on to the left. It also cannot jump over this dotted line over here. And so that green line and that purple line are what we call asymptotes. They get in the way. Okay? But if we can visualize a parabola, with this parabola we can see that it is completely free to move. There are no lines that are getting in the way of this parabola. And so we say that parabolas have no asymptotes. There's no lines that are getting in the way. We will now look at reflections and translations. So let's look at a few examples or a few ideas of what we mean when we talk about a reflection, and then we will have a look at what we mean by a translation. Here we can see a parabola on the left hand side that has coordinates 0, 5 and 3 and 4. When you reflect something in the x-axis, which is this green axis over here, then you flip the value or the parabola over that line. So it's almost like the mirror image. So notice that the graph is not moving in a horizontal direction. So the x values of each coordinate stays exactly the same. Notice, however, that the y values have changed. For example, in this drawing, the y value is 5. In this one, it is minus 5. Here we have a y value of 4, and in the one below, it is minus 4. But notice that the x values have not changed. Let's do a few examples. Sometimes we reflect the graph in the y-axis instead. So notice that in the first parabola on the left, so we take that parabola that's on the left and we reflect it in this direction across the y-axis. And so all the y values will stay the same, but the x values will become the opposite of what they were. So if we take this coordinate, the y value still stays 3 because the point isn't moving upwards or downwards, but the x value switches to minus 7. Similarly, this y values this x value just becomes minus 4. And that is what we call a reflection in the y-axis because we're jumping over the y-axis. We are now going to look at translations. Here we have a parabola drawn on the left that then gets shifted in a specific way to become the parabola on the right. I do apologize that the two parabolas look totally different. That is just due to my bad drawing skills. The point is that the two parabolas are actually the same. The first one, which is the one on the left, has been moved to become the one on the right. And so we can see that there's no reflection that has taken place. What has happened is that the x value has been moved 6 places to the right, because to go from minus 2 to 4 would have to add 6 places, and the y value has gone up by 4. So it goes from minus 3 up to 1 over here. So this parabola has shifted 6 units to the right and 4 units up. We can now practice some examples. So let's start with our example. In this question, they've given us an equation, which is the y is equal to 2x minus 1 squared plus 4, and they want to know what the new equation will be if we reflect the graph in the y-axis. All that you need to remember when doing this is to realize what changes when you reflect a graph in the y-axis. So remember, that means you're going to jump over the y-axis in this direction. So will your y values change, or will your x values change? It's your x values that are going to change. And so each x value just becomes the opposite of what it was. So if the x value was 5, it now becomes minus 5. So how do we modify the equation? Well, all you do, and it's so easy, is you go to any x value in your equation and you simply change the sign in front of it. So if it was a plus, you make it a minus. If it was a minus, you make it a plus. And so I will write down the modified equation for number 1a. So as you can see, the answer is y is equal to 2, and then the x value has just received a negative in front of it. If there were more x values in that equation, we would change each one. In 1b, it's going to be reflected about the y-axis. When we reflect something in the x-axis, we jump over the x-axis. And so what changes, the x values or the y values? In this case, it's the y values that change. So what do? We take the original equation and we change all the y values. But we're not done there, because an equation always has to have y by itself. So to get rid of the negative, we will simply distribute it, or we'll divide everything by a negative. So that will end up causing a negative to go in the front there, and it'll also end up switching that positive sign over there. So each term, because remember this over here is one term, and this over here is another term. So each term has to switch signs when you divide by the negative. And so your resulting equation is going to be, and so you can see there the final answer, each term has been flipped. So if you want to think of it that way, each term flips when we reflect in the x-axis. For 1c, we are going to translate this graph 3 units to the right and 5 units up. Now, visualize what that will do to the turning point. So what is the turning point of the current graph? Well, I'm positive that you guys have a deeper understanding of this now. This graph has been shifted 1 unit to the right and 4 units up. And so the current turning point for that graph would be 1, remember, because minus 1 means to the right, and 4. So what will that become if we translate the graph 3 units to the right and 5 units up? Well, that's going to cause the x value of the turning point to add 3, so it's going to be 1 plus 3, which is 4, and then the y value, which is currently 4, is going to add 5 because we're going 5 units up, and so the new turning point is going to be 4 and 9. The 2 in the front of the equation will remain unchanged because remember, that part tells you how wide or narrow the graph is, and if you are simply moving a graph around, you're not changing the wideness or how narrow it is. And so the new equation for that graph is going to be, and so the new equation can be shown in C, where the turning point has simply been modified. And so it's very easy to just modify the formula, and that will be the new equation. Part D says it gets reflected in the x-axis, which is what we did at B, and then we're going to translate it 4 units to the left and 1 unit down. So let's take the answer from B, which is the reflection in the x-axis. So I'll quickly copy that down. And now we can take that reflected graph, and it tells us that we need to translate it 4 units to the left and 1 unit down. So all you have to do is imagine what that's going to do to the turning point. So the turning point for this graph at D, as we can see it at the moment, says x minus 1, which means that point is currently 1 unit to the right, and it says minus 4, so that point is currently 4 units down. So if we translate it 4 units to the left, well, where will we end up? So imagine you are 1 unit to the right, and then you move 4 units to the left. Well, then you're going to end up at minus 3 on the x and y diagram. So if your turning point x value is at minus 3, what would that have to say in brackets? Well, that would have to be x plus 3. And then if your y value of your turning point is currently at minus 4, well then if you're still going to move another 1 unit down, then it's going to go down to minus 5. And so the new equation is going to become, and now we can go try another example. So the first question says that this equation is reflected in the y-axis. So remember, that doesn't necessarily mean that the y values change. You should always try to visualize it. So if you have a graph that is reflected about the y-axis, it means that the graph is going to jump over the y-axis. So what changes if you jump over the y-axis? Is it the x values or the y values? It's the x values, right? So all the x values become the opposite of what they were. So we simply go and add a negative in front of the x in that equation. And so the answer will be listed shortly. And there we can see that the x value has become a negative. Then we are going to reflect it in the x-axis. So remember, what that means is when you reflect something in the x-axis, it means you are going to move vertically, and so all the y values become the opposite of what they are. So what you do is you put a negative by the y value of the current equation, and then remember, we can't leave that as a negative because a standard equation has to have y by itself, and so we divide by negative, or negative 1 if you'd like to think of it that way, which means that each term, of which we have 2 terms, this would be your first term, and this would be your second term. Each of those are going to have to switch, because when you divide by a negative, it's going to cause the signs to change. And so there the new equation can be seen where each term has been flipped. Now they're going to, in C, they ask us to translate the graph 4 units to the left and 5 units up. So remember, when you transfer a graph left and 5 units up, that will modify the turning point. And so let's quickly plot a point of where this turning point of the original graph currently is. So we're going to have a look at this over here. X plus 3 means to the left or to the right. That means the turning point is currently on the left. And this minus 5 means that the graph is currently 5 units down. And so the point is located somewhere over there. So we can see that point that's currently at minus 3 and minus 5. Now, that point is going to be modified. So they tell us it's going to be modified 4 units to the left. And so that means the x value is going to go to minus 7. And then 5 units up. It's going to go 4 units to the left. And then it'll go 5 units up. And so it would end up with coordinates of, and so the new turning point would be at minus 7 and 0. And so that will modify your formula slightly. So in brackets for the turning point, would it say x plus 7 or x minus 7? It's going to say plus 7 because we've moved 7. We are now 7 units to the left from the origin. The new equation of the graph is therefore going to be, and there at number 2C, you can see the new equation has been drawn. Notice that the turning point is at minus 7, and so in turning point form that must say x plus 7. And remember, the turning point's y value is 0, and so we don't have anything added at the end there. We could say plus 0 if you want, but that's not necessary. And so that is the new equation. Remember that this x plus 7 that you can see in the equation doesn't tell us that the graph moved 7 places from where it was before the shift. All it tells us is that the graph is now 7 places from the origin of the graph, which is this point over here. That's what it tells us. And the last part of this question is D. It says that the graph must first be reflected in the y-axis, which we've done, and then after that it must be translated 2 units to the left and 1 unit up. So in number 2a we already reflected the graph in the y-axis, and so we can write out that equation so long. As you can see, the equation from number 2a, which we did where we did the reflection about the y-axis, has been presented. Now we are going to take that and we are going to translate it 2 units to the left and 1 unit up. So this one's a little bit weird because of the fact that in the bracket we have a minus x already, but that's okay. All that we have to know is that when you move a graph to the left inside this bracket, do you say plus or do you say minus? Well, when you move to the left, you should say plus. Remember, it's always opposite with x values when you're shifting left and right. And then the 1 unit up, well, that's going to be easy. We'll just modify the minus 5. So what it will look like is the following. And so there you can see how we have shown that the graph is going to move 2 units to the left. And that we showed over there, and then 1 unit up. So now what we can do is just go simplify inside the bracket, and we can also simplify this part over here, and so the resulting equation is going, and there we can see the final equation for number 2D, and that is the end of this video.